Once again, everyone, thank you very much for joining us for our PDW Industrial Wireless Products webinar. There's a lot of new features on these products that we want to take a look at. We are going to go through them fairly quickly today because I want everyone to leave here with an understanding of what these products are, and there is a lot to go over. Before I get started, though, there are common questions I get, and I wanted to jump right in to answer those for you. The most common question I get is, can I get a copy of the slides from today's webinar? The second most common question is, can I get a recording of this? Because I'd like to share it with someone who perhaps couldn't attend. We will be sending out an email with both of those things, the slides and the recording of the webinar, probably in a day or two. So look for those by the end of the week in your inbox. I'd love it if you do share it, if you know someone who should see what we talk about here today. Also, you have probably noticed you are in listen-only mode. There are too many people in attendance at these sessions to have all those dogs barking, doors slamming, and cars driving by. However, if you want an opportunity to ask questions, please do so. There is both a chat and a Q&A option, probably at the bottom of your screen if you're on your desktop. And I will pause periodically to answer any questions people may have or to address any comments people want to leave in the chat. Finally, at the end of today's session, you may see a survey pop up. If you're one of the people who does, I would really appreciate you filling that out. It's how I get feedback on how I've done, and it's how we get ideas about what other people would like to see, rather than just us making it up in our next presentation. So if you've got thoughts on what you'd like to see or you have any feedback on how we do today, please go ahead and let me know. With that, I'm going to turn my camera off so that everybody can focus on the slides, and we're going to get started with today's presentation. So again, we are here today to talk about the PDW Industrial Wireless Products. And specifically, we're going to spend a minute talking about the new explosion-proof approvals that are on our various field units. What you see here on this front page here is our PDW30 on one side and our PDW90 system on the other. And we're going to deep dive on all of those so you will know what I'm talking about by the time you leave here today, or at least that is our goal. Allow me to introduce myself. My name is Joe Ryan. I'm a VP of Sales and Marketing here at Precision Digital. I've been in the process industry, either designing products for it or selling and marketing products for it for over 20 years. So I've got some extensive experience that allows me to address whatever questions you may have and really talk about how these products work from both a technical side of things as well as an applications side of things. The agenda and takeaway for today. Well, first, we're going to talk about the new safety approvals. Then we are going to go over the flexible wireless I/O solutions these help you offer. We're going to take a look at the actual specifications for some of these, as far as how many I/O they can have, things like that. But we're also going to then look at actual examples of these setups. We're going to give some drawn out pictures that will help me walk you through how these actually work, and I think will make you understand what these products are much better than just trying to describe it. And of course, I want you to understand the key specification for wireless products, which is that we offer 1 mile outdoor or 500-foot indoors wireless range. Now, that 500-foot indoor wireless range varies, of course. It's easy to gauge your distance when it's outdoor line of sight. Indoors, why do we say 500 feet? Well, we think it's a good conservative estimate of what you're going to get. I know these are going into harsh industrial environments, lots of wall, pipes, cement construction, generators, all kinds of interference. So we don't want to promise you something you won't get. You might be able to get longer than this 500 feet, but we say 500 feet because we are pretty happy with the performance of these products at that range, even in a tough environment for wireless signals. I also want you to know that these are IP68, Type 4X, and NEMA 4X enclosures. So these are rugged, outdoor-worthy enclosures with a broad operating temperature range going all the way down to -40, which makes them great for applications in all of you northern states, or even some places like Texas, where you just really want cold weather protection. And finally, the spec you need to know is that these are 9 to 30 VDC powered. These are not devices that are battery powered. They do require line voltage. Now, you may be able to get that 9 to 30 volts DC from a solar system or a battery, but that's on you. We offer these as line powered to communicate as fast and as often as possible. We did not make these specifically low power battery powered devices. So Be aware of that you really would like to have some kind of 24-volt power available wherever you're looking to install these. And those are those key specs that you really got to know. There's a lot more to cover though, so let's dive into that. The newest features that we've added to these products are the explosion-proof approvals. People have been waiting on these for a long time, so I'm very happy that we can finally roll these out. So what exactly are those approvals and what are they on? Well, we are talking about approvals for essentially any of these metal housing products that you're going to see today. So that could be a pair of PDW30 wireless bridges. That could be our PDW90 field units or the repeaters, which are individual units, the way they're sold. But anything you see in these blue aluminum or these stainless steel enclosures, those are the products that now carry the explosion-proof approvals. The PDW90 base station, which is what these plastic boxes are, you see down at the bottom, those are now Intertech ETL certified for general safety areas, which means they carry sort of a basic safety approval, but not for hazardous areas. They're only things that are going to go in your safe areas. But typically on the PDW90s, those base stations are designed to go where your people are going to be and want this data. They're going in control rooms. They're going in control stations. They're not going to be out there at the top of your fuel storage tank, your oil tanks. That is really what the field units or the PDW30s are for. And that's why we have that approval on all of these aluminum or stainless steel housed products that you're going to see today. Here's the actual approvals that we have on these products. So you see we've got Class 1, Div 1, all the groups, Class 2, Div 1, E, F, and G. If you are into zones, well, we have zone approvals well. So if you're a little more modern and you prefer the zone approvals, we've got Zone 1 and Zone 21 approvals. Although I will say Class 1, Div 1 seems to be what most people are looking for. And if you're wondering about, well, ETL and interlock, you're not very familiar with what those are, be aware that that means they conform to the UL standards listed here. So essentially, they are the same standards that you would get something approved to from UL. It's the same type of standards that they conform to with all the same specifications, et cetera. It's just a different testing agency. Now, I've talked a little about the PDW30 and PDW90 as specific part numbers. Let's talk about what those actually are and what the differences between the two are. So the PDW30 is a point-to-point wireless bridge. That means it's designed to take what would otherwise be a wired signal, cut it in the middle, and replace some of that wire with a wireless bridge. These are explosion-proof. You'll notice that when you look at PDW30s, they are always sold as a pair. So for example, this aluminum pair on the right, that would be what you get when you order a single PDW30 part number. Both of those parts of that PDW30 carry that ETL hazardous area certification because both of those are in those metal housings. The PDW30 is also designed to be incredibly easy to set up. It works right out of the box. If you have multiple PDW30 units in your facility, you may need to change a network ID. If you want to use the discrete I/O, you may need to configure them as inputs or outputs. But that is super simple setup. You can do it in the software we have for setup, but you don't even have to do that. It's just so easy to do. These are really designed to be a very, very simple, easy to deploy solution when you want to get a 4 to 20, a discrete signal, or an RS-485 Modbus signal from one point in your plant to another. Along those lines, it's worth noting that every one of these boxes, so for example, this is two sides of the PDW30. Both of those sides of the PDW30 link have a 4 to 20 milliamp input, digital inputs, and RS-485 for Modbus. Both of them have, as outputs, a 4 to 20 milliamp input, digital outputs, potentially 2 relays, and Modbus. Both units have both sets of I/O. We'll see why that can be valuable to you in a minute. I mentioned there's a PDW manager with onboard USB, but I'll tell you on the PDW30s, you don't really need it. These are just so simple to use. I generally don't even recommend people bother with the PDW manager unless there's some advanced settings they want to use. You'll see there are buttons on the front. Those are capacitive touch buttons. So if you want to make any of those changes through the front panel, after installation. You can do that without having to unscrew your lid. The most common thing somebody uses those buttons for on a PDW30 is to change what the display is showing. You might want to see, for example, what these are showing here, which is your link status. Are they wirelessly connected? Or you might want to see what the state is of your digital I/O or what your milliamp values are. And in that case, you can cycle between screens that will tell you that. We now, and this is a new feature, have two Form A relays that you can fit into this enclosure. So at the bottom of this box, you can actually get two relays in there. If you want to have some 5-amp relays, because the digital I/O is not going to carry enough current for you. And once again, they're IP68 Type 4X. Their operating temperature brings it down to -40, and they're 24-volt power. A very valuable tool we'll look at the end here is this PDA10 signal strength survey tool. A main question people have in wireless is, will the wireless signal work in my application? Will it go from where I want it to where I need it to be? And the answer is most likely, but you can be sure if you use a PDA10 signal strength survey tool. Taking a brief look at those enclosures more close up, they've got all the features you need to be able to get your installation up and running. You've got stainless steel tag attachment loops. You've got tamper-proof seals if you need them with locking screws. It is worth noting that these are some of the only precision digital products that have a display but don't allow you to scale that value. You can see your link status, your RSSI signal strength indicator, the milliamp inputs and outputs, and the digital I/O states, but you don't scale it here. You can't set alarms here. That's more of the purview of our panel meters and our field mount displays. That is not what these products are for. Taking a look inside, you'll see that once you remove the cover, it's very easy to pop off your electronics module. If you did want to program it with the software, it's really easy to take that out, bring it to your computer, plug it into USB, and then bring it on back and just snap it right in. There's no tools you need. There's no hardware involved. In the bottom of the enclosure is where this relay expansion module goes. If you want some more powerful outputs or some more capable current carrying outputs than your digital outputs will provide, the relays are a great option for you. You can tie your digital output circuits to this connector here, and then you've got your two 5-amp Form A relays available at the bottom. It is worth noting that we can install this at the factory as part of the hazardous approvals, but if you install it after the fact, it does not have the hazardous area approvals. Because it is an approved product, it does require us to do the assembly of it here at the factory if you want to use the relay module with your hazardous area approvals. They are available in painted steel and aluminum. So you can take your option. Obviously, most people get the painted aluminum rather, but the stainless steel is popular when somebody's dealing with particularly harsh chemicals and they need to make sure that their enclosure is going to hold up. However, both of those are certified for hazardous area use as explosion proof. They both have that IP68 Type 4X and NEMA 4X rating. They mount very easily onto basically any surface you've got, whether you want to wall mount it or you want to pipe mount it or you want to rail mount it, because of these integrated mounting flanges. And once again, right down to -4. So now that we've looked at the PDW30s, what do you do with these? And what do you use the various I/O for? I think this will really help you understand the product better. So here's a fairly simple application where you would use a PDW30 point-to-point wireless bridge. Out in our field, we've got a tank located in a hazardous area. On that tank, we've got a 4 to 20 milliamp level transmitter. I don't want to run that signal wired. I'd really like to go wireless, which means I can go up to 1 mile outdoor line of sight or 500 feet indoors. So what I'm going to do, and by the way, what you don't see in this picture, before I get started, I should mention this, what you don't see in this picture is the 24-volt wire. So somewhere I've got 24 volts DC running into this field enclosure here. And somewhere I've got 24 volts, technically 9 to 30, right? But I've got 24 volts DC that is powering my other field enclosure in the safe area. So though you don't see it in this drawing, they both need to be 24 volt powered. That having been said, once again, I've got my 4 to 20 level transmitter, and my 4 to 20 signal is going into my PDW30 secondary unit. Why is it going into the secondary unit? Well, we'll get to that in a little bit, but there are two sides of this. Communication does go both ways. However, there's one application where you do need that secondary and primary, and where it does matter. We'll cover that in a minute. But anyways, I've got my 4 to 20 go from my level transmitter going into my field unit. Through the magic of wireless, it then transmits over to my PDW30 primary unit. And whatever you bring in then comes out of the other side. So I'm bringing in my 4 to 20 on the left. So on the right, I'm getting out my 4 to 20. I need something to scale this, have alarms, have relays. And so we put a PD6602 loop power display on that 4 to 20 milliamp output. That is your most basic application for these. However, in this scenario, we're doing a little more. We have a loss of signal output that's going to go to a PLC, so we can send alerts if we lose our wireless connection. And our loop leader, our 6602 loop powered display down the bottom, has a couple of relays on it. And so we have a high alarm and a low alarm relay. And those relays go into the digital inputs on the right side in the safe area. And remember, whatever I put in is what I get out. So I'm putting in some digital inputs on the right, which means I'm getting out digital outputs on the left. And I'm using those digital outputs, or if necessary, the relays, to drive a high alarm and a low alarm horn and light over in the hazardous area. So I am bringing in a 4 to 20, sending that in one direction, and then I'm bringing in my discrete I/O, and I'm sending those digital inputs to digital outputs or relays going the other direction. That's what we mean when we say that these communications go both ways. There's not a single receiver and transmitter. It's not like I bring everything into one side and it goes to the other side where it goes out. I can also have signals coming back in the opposite direction. So you can both send information out to the field and get information back from the field with the PDW30. And what's great about this setup is if I were to cut my wireless units out of this scenario, and instead I had just hardwired everything, where my 4 to 20s went to the meter and my digital IOs just directly drove these lights and horns, it would work exactly the same. The devices that we have connected these wireless units to, they have no idea that within this box is a wireless bridge. They all just act as though they were wired up units. So you don't have to have any kind of special equipment to talk a certain kind of digital signal. Everything works exactly as you'd expect with these wired signals. We're just breaking that line and we're putting a wireless communication bridge in the middle of it. That setup that we just saw uses one PDW30 pair part number. When you buy a PDW30 pair, one part number gets you both your primary and secondary units. So you buy that one part number and you get a box and it's got two units in it, two blue field units in this case. We're also using the two Form A relays to drive the lights. And we've got the aluminum enclosures on here, though it could be stainless steel if that's what you need. It's worth noting that Precision Digital does offer lights and horns, though they are not suitable for hazardous area, which was what our example was showing. And we have the PD6602 loop powered meter, which is what we're scaling and displaying our values on, and also what's driving those alarms. So these are the part numbers that we used in the application we just looked at. Here's another example. This is very similar in that I've got the 4 to 20 signal coming into my field unit, my primary in this case. And then I've got that 4 to 20, what goes in comes out, coming out of my secondary unit. That's, in this case, going to the same 6602 meter. But in this case, rather than driving relays that go into the digital inputs, we have an operator who's using one of our PD460 valve positioners to manually dial in the position of a valve, open it up, and fill up that tank. So the operator manually adjusts this 4 to 20 milliamp input that then goes into my secondary. And then that is the 4 to 20 that then comes out of my primary, which goes to the digital valve positioner. So once again, the idea here is everything I take in then comes out the other side. And I've got a 4 to 20 going from my tank to my control location, and from my control location back out to the tank. Once again, the system just needs that one part number for everything that's related to the PDW30. So it gets you that PDW30 pair when you order that one part. And then we've got our 6602 panel meter, and in this case, our PD460 4 to 20 milliamp valve position controller. We're talking about 4 to 20, so now is a great time for me to pause and talk about Tom's question, who asked, is the PDW30 milliamp input/output active or passive? It is an active output. You don't have to drive it with its own 24-volt supply. Because this is a DC powered unit, we have the power needed to drive that output. So it is an active 4 to 20 milliamp output. Now the inputs do not have a separate power supply. So you want to take an active input and send it into the unit if you're going to be doing that. You could theoretically just use the same DC power supply that you're using to turn on the wireless unit to power an input loop. But that gets into some isolation questions that may or may not be appropriate for your application. But the input doesn't have a separate isolated power supply like you might find on, say, a ProView or a Trident meter. But the outputs are powered outputs. Now, if I need a little bit longer range, you'll see this is the application we looked at earlier, bringing a 4 to 20 milliamp in from the tank level transmitter, sending that eventually over to our display, and then bringing back that digital input based on those alarms and using them to turn on lights in the field. However, if I need that range, you'll see what we've done here is we have put a repeater in the middle. And a repeater essentially gives you another hop of that range. So now I can go from my secondary unit out of the tank to my repeater, and that specific jump has 1 mile outdoor line of sight for 500-foot indoor range. But then the repeater to the primary unit gives me another 1 mile outdoor line of sight or 500-foot indoor range. So having that repeater located in the middle, which again has to have its own DC power supply to run, having that repeater in the middle allows me to get one extra what they call hop with those wireless signals. So it's a nice way to get some range that means I don't really have to mess with additional antennas. It's also a nice way to go around obstacles. Let's say in between my tank that I'm measuring and my loop leader on the right, I had a big giant tank that would prevent my signals from getting properly across, or I had a building located right here. Well, a repeater can be used not only to extend your range, but to bend the signal to create that path. So then, in this case, we have our PDW30 pair, but we'd also buy a PDW repeater, a PDWR. That's available in the same kinds of enclosures. It looks almost identical. The real big key with the repeater is its function is different because it's providing you a additional hop for your wireless signal. And also, it has no wired I/O. You just bring it power, and all it does is repeat those signals that get sent between these other devices. So you can't say bring in a digital input here and a 4 to 20 input here and have those all go over to the primary. That's not what happens here. The repeater is a self-contained box that you just bring power to, and all it does is provide you an additional hop. And actually, it looks like, Evan, that actually answers your question, which directly related to what are the inputs on the repeater? The answer is the repeater has no inputs. It is just a wireless retransmission device, essentially. So that's what our PDW30 is. It's an easy to install, quick to get running, wireless bridge system. You buy it as pairs, ready to be deployed. The PDW90 is a more advanced point-to-multipoint system, meaning that you are going from multiple field units in multiple locations, that's your multipoint, to a singular point, the PDW90 base station. So that is why we call it point-to-multipoint. It's the point out to multiple other locations. So what are some of the differences that we should note with the PDW90? Well, It's worth noting that the field units carry that explosion-proof approval. I'll say again, by the way, that many people get these products that don't need the explosion-proof approvals. They just like the idea of having that rugged field unit mounted out there in the field. If you're in water and wastewater, for example, you may not need this approval, but it is handy just to have a rugged standalone field unit. But if you need the approvals, we have them. The base station, which is what these plastic enclosures are over on the left, those are just general safety approvals. They do not have hazardous area approvals. This must go in the safe area. And we talked about the system architecture of it, meaning that you're going to need some form of base station, and we'll look at those in a second, and you're going to need some number of field units. So this is a much more configurable system because you can get up to 3 different sizes of base station, and you can get up to 32 field units, whatever it is you need to match up with the IO you're looking for. It has that same 1 mile outdoor line of sight, 500-foot indoor range. So all of that we talked about still applies. You can still transmit 4-20s, digital IO, or RS-485 Modbus. The interesting thing here about the base stations is that you buy modules to plug into it to get you additional IO. So the reason we have 3 sizes of fields of base station rather is that you have 2, 6, or 16 spots for you to put IO modules. And we'll see an example of what that looks like in a moment. It is worth noting that even the base station is Type 4X and NEMA 4X, so all of this can still be put outdoors, no problem. It's still wash down, safe, capable, etc. The base station also goes down to -40, and it requires that 9 to 30 VDC power. Here's a bit of a closer look at those 2 units. You've seen a lot of what the field unit looks like already. It's essentially the same thing as our PDW30 bridge. But let's take a closer look at that base station. So this is a plastic NEMA 4X box, as opposed to the metal of the field unit. It has a more basic antenna. It doesn't have any of the hazardous approvals, and therefore it doesn't have to have that hazardous area antenna. There is an LCD screen inside of the box that really just shows you the current field unit signal strength. So it shows you what the field units, each of the field units, and what their connected strength is. And while it comes standard with RS-485, if you're going to be communicating via Modbus through it, the other signals connect up in these slots you see here in the middle. And so what you see in this picture is you can see the empty slots, which is what you see. So for example, here at the bottom, you've got a rectangle printed on the bottom board with a connector spot for whatever module you're going to connect in. And then you've got the wiring connector that is that is labeled specifically for the module you get. And here you'll see modules installed. You buy these little black boxes that come with a connector header, and you just plug them in to various spots on the board. There are modules that have dual analog inputs, 2 analog inputs, dual analog outputs, so 2 analog outputs, 4 digital IO, or 2 relays. So each one of these boxes, I could have 2 analog inputs here, 2 analog inputs here, 2 analog inputs here, 2 analog inputs here. And if I did that, I could, in theory, have 8 4-20 milliamp signals coming into my base station. And remember, what goes in comes out. So that would have to be paired up, presumably, with 8 field units that would then each be outputting 1 4-20 milliamp output. That'll make a little more sense to you in a second when we look at some actual examples. So once again, you can get your base stations in 3 sizes. They're all NEMA 4X, Type 4X. You size it based on how many IO modules you want. If you only do Modbus, or you only need a few modules, you've got a small one, all the way up to the larger one that can hold 16 modules, which in theory lets you connect up to 32 field units. The field units are much of what you've seen in the PDW30s. As this area approved, they're aluminum or stainless steel. They've got that same built-in mounting mechanism with the flange on the top for pipe mounting, wall mounting, rail mounting, etc. You will be programming the PDW90 with the PDW Manager programming software. You have to use this. Because you have to map some of those field units to your various modules in the base station, you must use the software to configure this. It's not particularly complicated, but it is something you have to use the software for. So you just connect your USB up to your base station, power on your field units, and start mapping all of this. There are capacitive through class buttons on the field units, but that's just for making minor changes. You do have to do the programming on your PC. To install those modules that you get, which again are either 2 analog inputs, 2 analog outputs, 4 digital I/O, or 2 relays per module, you buy the base station, you buy the modules separately, and then you just snap those modules down into the base station and plug the header in that's labeled appropriately for that module. Much like the PDW30, the field units do have a 2 relays option module if those digital outputs on the field units are not going to be able to carry enough current for it. So let's take a look at a couple PDW90 applications so you can have a good understanding of how those work. This is an expanded example of the PDW30 application we saw earlier. In this case, I've got 2 tanks, tank 1 and tank 2, but each one of those is doing the same thing that we did previously. So each one has a level transmitter that's bringing a 4 to 20 milliamp signal into a field unit. That field unit then, through the magic of wireless, connects up to the base station. And you'll notice on each one of those, I have my 1 mile outdoor line of sight, 500-foot indoor range. Now, what comes in goes out the other side, right? So I'm bringing in my 4 to 20 milliamps into the field units. And so I'm going to get out a 4 to 20 from the tank 1 level transmitter, and I'm going to get out a 4 to 20 from the tank 2 level transmitter. Then, just like before, I'm going to set my alarm relay set points on the 6602 and bring those relays into digital inputs on my base station. And I'm going to do that for both of my loop-powered indicators, which are then going to go from digital inputs to digital outputs in the field unit, where I'll use either the digital outputs or the relays to drive those alarm lights. So to do this application, my base station has to have a total of 2 4 to 20 milliamp outputs and 4 digital I/O. So I have 1 4 to 20 milliamp output module, and I have 1 4 digital I/O module. So in this case, I only require the 2 module base station. And once again, I've got communication going in both directions, and I'm going from my point, which is my PDW90, out to my multi-point, which is each one of those field unit locations. So to build up that application, it's a little more complicated than your PDW30. I need my 2 I/O slot base station. Then I'm going to need a 2 analog output module. And I'm going to need a 4 digital I/O module. And I only need 1 of each. So that is what my base station will look like. Then I need my field units. So I need to get 2 field units, 1 to go on each tank. And then what else you saw there were the lights and horns. So we have 4 of those, high and the low on each of the 2 tanks. And the 2 loop-powered indicators with relay outputs, which were what were displaying my scaled value for the level and driving the alarm relays. If you take it to its extremes, you can have an application such as this. Here I've got the same tanks out in the field connected to level transmitters, but I've got 32 of them. So each one of these transmitter points is actually a level transmitter putting a 4 to 20 milliamp signal into a field unit. And then every one of these multi-point locations is sending its data to the base station, where I've got 16 dual 4 to 20 milliamp modules. So 16 times 2 gives me my 32 4 to 20 milliamp outputs. And so I'm taking those 4 to 20 milliamp inputs from the field, and I'm outputting all 32 of them as 4 to 20 milliamp outputs into a PLC at another location. And with the new approvals on these, this could all be in my hazardous area, sending the information to my safe area. To do a setup like that, you're going to need one 16 module base station, so it can hold enough modules to handle 32 outputs. And then I need the 16 dual analog output cards for modules to generate those 32 4 to 20 outs. And then I will need 32 field units, one to go on top of each one of those 32 tanks. To give just a more likely scenario, we don't see many fully populated 32 module systems, but you could do that. Perhaps this is a more standard one that we can see, which is I've got 4 tanks out in the field. And in this case, I've got 4 transmitters, one on each tank going into the field unit, which transmits wirelessly to the base station, where it transmits a 4 to 20 milliamp output out of those dual analog output modules. So I've got 4 to 20 milliamp inputs coming into my 4 field units, which come out of the 2 modules, each with 2, so out of these 4 to 20 milliamp outputs. And in this case, we've got that going into our consolidator plus. So one location will display with bar graphs and color 4 tanks and their levels. The hazardous area contains the field units, the safe area is the base station. And now I only need a 2-unit base station again, 2 modules, and I need those 2 dual analog output modules, and 4 field units. And in this case, we connected them all up to one consolidator plus as a display. One interesting thing about the PDW90 system is that, like you saw with that 32 milliamp example, or I'm sorry, 32 4 to 20 milliamp example, there could still be a lot of wires involved. You may not have to run them all long distances, but you still do have a lot of wires if you're using only 4 to 20. And so it's worth talking about how Modbus fits into all of this, because it's a great way to reduce the amount of wiring you have even further. So in this scenario, we're going to use Modbus. And so we've got our Modbus RTU sensor, which is a level transmitter with RS485 Modbus. And we connect that 3-wire Modbus in between the level transmitter and the RS485 input on the field units. On the base station side of things, we are going to connect our base station's Modbus inputs, the RS485, to our consolidator plus, which has the ability to be a Modbus client, or in the past that was called a Modbus master. And so what's going to happen here is the Modbus master is going to make a request of the base station going into its RS485 connection, which it comes with standard. I don't have any modules installed in this case. And it's going to take that Modbus request, and just as if it were a really big wired Modbus 485 bus of wires, it's going to send that command out to my field units that are all going to make the request of their 485 buses. So if the consolidator is asking for, let's say, tank 1's information, right, it's going to say, okay, transmitter on tank 1, give me your level. And it will get transmitted out to that broad 485 network. The unit with tank 1 on it is then going to receive that, and it's going to respond. It's going to say, great, here is my level. That's going to transmit back to the base station, which is going to return that command to the Modbus master. So now, in this case, I've got 3 field units wired up, which, connecting up a 3-wire 485 is roughly the same thing as connecting up a 2-wire 4 to 20 milliamp signal. So in the field, it doesn't save me a lot. But back here at my base station, I now only need to wire 3-wire 485 between my consolidator and my base station. I don't have to run a bunch of individual 4 to 20 milliamp signals. A few other advantages of going this road are that if I have additional information I want to take out of my level transmitter, let's say it was actually a multivariable transmitter and I had water oil separator tanks here, I could take the top level, the interface level, and the average temperature, let's say, and pull all 3 of those variables out of this with just one 3-wire 485 connection. So it lets me get more information out of my transmitters if I have more information to get. And also something else we've done here is we've attached one of our 6730X Modbus snoopers as a tank side level indicator. That's a product that sits on the 485 bus and listens, never talks. It just listens for a specific variable to get called for, and then it captures it and displays it. So now I can easily attach a tank side level indicator that will always show that Modbus variable locally. What does it look like to assemble that application? Well, I need a base station. And in this case, we're not using any modules, so we're getting the smallest base station off. Then I need the 3 field units, 1 for each tank. And in this case, we're getting our consolidator plus, so we can display all those variables and great display, nice color display for someone to read. We're getting our Modbus client snooper spoofer package, so we get that Modbus master capability. And if we want to put those Modbus tank side indicators there, we need 3 of those PD6730Xs. To drive that point home even more, let's take that extreme example we talked about, the maximum possible 4 to 20 milliamp example. We had 32 field units with 32 4 to 20s and 32 4 to 20s coming out of our base station, right? Well, that'd be 32 4 to 20s I have to wire between my base station and my PLC, or in this case, my consolidator plus. Well, if we used Modbus for that, each one of these field units would only have the Modbus 485 wired between the level transmitter and the field unit. And that's roughly the same as doing a 4 to 20 wire would be. But then back at the base station, instead of wiring at least a pair of wires for each 4 to 20, so I got to do 64 wires from my base station to my PLC or my consolidator plus. Now this connection is just a 3-wire 485 bus. So I just saved myself a whole afternoon of labeling wires, stripping wires, installing wires, and I just put an RS-485 3-wire cable between the 2 of those. So some significant time savings if you get into these large number of signals to just go with Modbus. And that system would look like my minimum size base station, the 32 field units, and then again that consolidator plus with the Modbus master package added. I'm going to pause there for a minute. I got a couple of questions that are worth reviewing. Walter, you had asked how fast the information updates from each point on the PDW90. What's the scan time? Let's say for the max IO. Well, that's a great question. I don't have a super clear answer for you. What I'll say is from my experience, if you really tax this out and you're looking at 32 different things that you're scanning across, trying to pull in that information from 32 field units going to a base station, you could be talking a few minutes, might be 2 minutes to get all that updated. The reason I say it's kind of interesting and I don't have a clear answer is it depends on how strong those wireless connections are, how many repeat transmissions are required. I mean, you're talking 32 signals, that can make a difference in time. In a typical application, I'd say we were talking 1 to 8. It updates pretty quickly. My experience has been you can actually stand there and change the inputs and watch the outputs change a few seconds later. So it is fast, depending on what your definition of fast is. But at the maximum extremes, if things go poorly with the communication attempts, you're getting a lot of dropped packets in the wireless transmission. You've got 32 things you want to scan across. Yeah, you might be seeing up to a minute or 2 to get all of those scanned across. So now we've talked a little bit more about the PDW90. You understand that better. Let's look at a real-world application we've come across, this time in a municipal wastewater plant using our PDW90 point-to-multipoint system. So why did they want the PDW90? Well, over on the left, you're going to see a picture of the actual site. And where they wanted all these signals to go is this location here in the middle. They eventually wanted to bring 8 4 to 20 milliamp signals to their central building. Where were those 4 to 20 milliamp signals coming from? Well, up north at the top of the picture, they had a chemical storage building. So in this building, they're doing chemical bulk storage, and they had 4 tanks, and they had a level transmitter for each of those tanks. But they had to bring that 4 to 20 halfway across the facility. That's obviously a bit of a pain, but at least that you could run as a single bundle. But then they also had signals at sedimentation tanks and digesters in the lower southern part of the facility. And even those weren't actually located together. So they also would have to run signals down to the left, down to the right. Next thing you know, you've got a project to run wireless signals all over your facility. I'm sorry, run 4 to 20 signals all over your facility, going in multiple directions. And you've got to find a way to do it, right? Your facility is pretty open, doesn't have a lot of places to put these wires in existing conduits or run overhead wires or things like that. This turned into a pretty significant project if they wanted to do wired connections. They had tried in the past to do wireless setups. Literally, we could go on site here and see other wireless systems that were bolted on the walls and installed up the poles, and they just never got them working. Any of you in the audience here who have seen wireless systems in the past know that they can be pretty complicated to get up and running. Our systems are specifically designed to be able to be spec'd out, purchased, installed, and programmed by your standard operator. You don't need to have a degree in serial communications to be able to get these systems up and running. And because our specifications on ranges are pretty conservative, you don't have to optimize everything in order to actually get them to work. So what does it look like installed in the field? Well, those field units are mounted directly at each location for the transmitters. So here's the transmitter on the outside of that chemical storage shed. Here's one of the transmitters at a sedimentation tank. And what's nice about these installations is you'll notice they put the antennas up nice and high. It's always great to get height. Not only does it help with that outdoor line of sight being line of sight, but it also gets it away from potential interference points along the way. It gets it over walls, gets it out of the pipe networks, etc. The designs are small, compact. The antennas are mounted directly to it. So very easy just to mount that enclosure with its attached antenna onto basically anything you have around. You'll notice the one on the left here, they mounted it right on the side of this sort of shed on the top of the building. And on the right, they just put it on the top of this electrical enclosure. Here, they only needed the painted aluminum. However, I certainly have seen chemical bulk storage applications where folks are worried about corrosion on aluminum, and they go with the stainless steel. And obviously, any kind of salt wire application, I always recommend stainless steel. The paint on the aluminum, of course, will make it pretty rugged, but you get scratches when you install these things. You get conduit entry points that corrode. So salt water applications always recommend stainless steel, but some chemical applications as well. This was also an ideal application for the wireless products because 24-volt power is readily available. They already have a 24 volts at all these sites. That's what they're using to run these transmitters. And so it was no big deal that you had to run 24 volts to the wireless units themselves to power them up. All of that information came back to a base station that was mounted inside. They really wanted to meet that line of sight wherever they could. And so you'll notice they installed the antenna on the side of the box, and they even knocked it to the side a little bit so that it was technically out a window, so it had line of sight to some more of their units. And once they brought all that into the central building, they could bring the 4 to 20 milliamp signals right into their SCADA system. So they have 8 field units, each one taking in a 4 to 20 milliamp from a tank level indicator, from a tank transmitter, level transmitter. And then those 8 level transmitter 4 to 20 milliamp signals all get transmitted wirelessly to the single base station, where 8 4 to 20 milliamp outputs go into their SCADA system. That's a great application showing you the kinds of possibilities you have here with these PDW30 and PDW90 systems. I'll note we're looking at level transmitters, by the way, throughout this presentation because it's incredibly common. But any 4 to 20 milliamp Modbus or discrete I/O signal will work here. It doesn't have to be level. Before we wrap up, just a couple of other products you'll want to be aware of. We talked about the repeater a bit. Again, you don't have any I/O on the repeater. It's just to provide additional wireless hops for that 1 mile outdoor line of sight or 500-foot indoor range. Very easy to configure these to work with your specific wireless network. You generally don't want to mount an antenna directly parallel and close to a metal grounded pipe. And so we have a mounting offset kit that will let you pipe mount a PDW wireless field unit to either 1.5 inch or 2-inch pipes, and it offsets the antenna from being directly next to that grounded metal pipe. We also have a mounting kit for our antennas. So if you need to remotely mount the standard antenna these come with, we've got a mounting kit that will let you do that. The relay module that's available for the field units and the PDW30s, though I'll remind you, buy it with that relay module installed if you think you might need it and you want to use the hazardous area approvals, because adding this module after the fact, while possible, isn't valid with the approvals. It has to be assembled at the factory with the relay module if you're going to use the approvals. Here's a close-up of what those base station modules look like. You see they're just a rectangular, fully sealed module that you snap into one of those slots that's available on a base station. And each one can either have 2 analog inputs, 2 analog outputs, 4 digital I/O, which could be either inputs or outputs. You just configure it for which one you want it to be, or 2 relays. If you do want to up power your antenna, we have additional antennas for that. I typically don't recommend people do this. Yagi antennas are certainly more powerful. We've got 3 dB and 9 dB Yagi antennas, but the Yagi antennas are difficult to aim. They've generally only got up to a 15-degree window that you really get fine transmission power or sensitivity, receptive sensitivity in. So you got to be really specific with how you're installing these. I'd personally rather just use a repeater than try to put in a Yagi antenna. But for those of you who are experienced with wireless and want to use these, you certainly can. Obviously, you don't want to use Yagis with repeaters and things like that, because again, you've got this very directional antenna, but they're available if you want them. And we do have a high gain monopole antenna. Then you don't have to worry about aiming the thing. It just goes off in every direction. These are a much easier antenna to work with, and that gets you a 6 dB as opposed to the 3 dB standard antenna. So you're talking significant gain in power there. Every 3 dB doubles power, I believe. So that's a nice step up if you just want that little extra power boost to make sure you hit your range. And of course, you need cables to connect your antennas to your field units and your PDW30 units. So we offer those 20-foot or 20-foot or 40-foot extension cable that'll get you the N-type fitting for the larger antennas. And on the other side, give you that RP-SMA connection that you need to connect to the wireless unit. Finally, I mentioned way back in the beginning, our PDA10 wireless survey toolkit, which is a kit in its own little carry case. It comes with 2 modules. The idea here is that you have a target, that's your module over here on the right, and you have a handheld unit, that's your module over here on the left. The way this works is these have the same antenna gains and the same wireless radios as what you'll get in the actual product. So you take your target, however, I will note these are battery powered. So you take your target unit out in the field somewhere, you put it at where, let's say, the transmitter is, and then you walk around your facility with the handheld and you see if you make your connection. Really handy when you're trying to make sure that you get your signal connection through, or your signal link through what might be a very tricky environment if you're worried about certain walls or tanks or obstructions along the way, because you can really find the ideal spot to put the other side of your PDW30 pair or put your base station to be able to connect to those field units. We sell these if you think you might have use for it. For example, if you're a precision digital distributor in the audience, like you see a number of you may just want to have one of these on hand. But for end users, we're happy to sell you these on a net 45-day terms. And if, as long as you return it to us, we give you full credit and you never have to pay for it. I do see a couple questions. If you don't mind sticking around for another minute or two, I'll answer all of those. I do thank you for your time. If you have to leave, please feel free. I know we're bumping up against 11 o'clock here. One question that came in, and this is from Thomas. He's asking, what's the frequency of these systems? Are they 900 megahertz? Are they 2.4 gigahertz? Are they other? So everything we saw here today is a 900 megahertz signal. That makes it appropriate generally for North America. In special cases, we have provided 2.4 gigahertz signals for international customers. We can do that. But typically, we sell 900 megahertz for the North American market. 900 megahertz is a great signal that goes through walls well, has good penetration. It's nice to work with. Then you've got a question from Zachary, or no, I'm sorry, Zachariah, who wants to know, are these signals encrypted? Is there any security involved here? So I'll say, first of all, yes, they are encrypted, and yes, there's security. Precision Digital did not become the experts in wireless communication security to make these products. We relied on a company that's well known in the industry. We use Digi wireless radios. They take care of all of that 120-bit AES encryption, the frequency hopping that 900 megahertz signal goes through to talk to each other. So we're relying on the industry experts for that because that's how we felt most comfortable providing a secure signal. So yes, they absolutely have those things. Those are some of those advanced features I might have mentioned earlier you could set up on the software. If you want to mask out certain frequencies or change up your encryption methodology, you can do those things with the software if you want to, though almost no application is going to need that. Most people are happy to use the default security because it is encrypted and strong. I think that's the last of our questions I see here. If I somehow missed your question, please just reach out to me after the fact. Otherwise, I thank everyone for attending today. I hope you have an opportunity to use these. I hope it was informative. Once again, if you see a survey when you leave here today, please fill it out. I really appreciate the feedback, and I hope to see you at a future presentation. Thank you very much.